All right, so chapter 3. We're still doing animals, starting with invertebrates. Okay, so invertebrates are organisms without a backbone, right? So you got a nice collection right here. Invertebrates, animals without a backbone. You got a really cool video right here. Click on it, take the time. It shows you Christmas tree worms. These guys are really, really cool. I want them in the tank someday. I used to have them a long time ago in my old tank, back when I was in high school. No comments. Really cool, guys. 95% of all known animals are actually invertebrates. Everything from the scalding deep sea hydrothermal vents to the rocky frozen ground of Antarctica. Everything from microscopic to 18 meters long. That's the length of a bus and a half, a school bus and a half. Okay, that would be the giant squid. Colossal squid, technically. Starting off with sponges, our beautiful sponges. In the classroom, I would be showing you all the beautiful specimens of sponges we have, but that's okay. So everything from a small sponge to this ginormous sponge, which is probably about 3 feet across in width, belongs to the phylum Porifera. We call it Porifera because they're full of pores. The water comes in this way and then out through the middle section, okay? And the way they're able to do that is they have these collar cells, and it's this flagellum that does this whip-like motion, bringing the water in through the pores and then out through this single central opening called the osculum, okay? These guys are very much suspension feeders, filter feeders, capture prey food particles floating in the water. The osculum is the central cavity where the water exits. They are hermaphrodites, meaning they function as both, but they'll actually take turns being male or female. Some sponges are used to help kill resistant strain of strep. So very, very important. Next, we have the phylum Cnidaria. It's a CN, but the C is silent. These are your jellyfish, your corals, your anemones. All right? Yes, we no longer call them jellyfish. We call them jellies. Diploblast, that means they have 2 germ layers, all right? The ectoderm and the endoderm. The endoderm is going to become part of the digestive system, and the ectoderm is what becomes, hang on, I'm having a blank. Endoderm is the digestive system. The ectoderm is, I know I did in the previous lecture. I'm a little out of it tonight, you guys, sorry. But they're diploblast. They have radial symmetry, meaning you can cut them like a flower pot, right? You can have 2 halves in multiple ways. We've talked about this before. They have gastrovascular cavity, 1 central digestive compartment. The same opening that's the mouth is the same opening that's the anus. So you will actually see your anemone using its tentacles to capture prey, bring it into its opening, and then later you will see that same opening poop. It's quite interesting. You have 2 variations of body plan, the polyp, which is this right here, where its base is actually attached. It's sessile, sedentary, stays in one spot. And then you have the medusa, okay, the jellyfish, where it's actually moving around, okay. The mouth down is version of it. This is more typical of your jellies, your jellyfish. This right here is the beautiful Portuguese man-o-war. Absolutely gorgeous. That's your hydra, and that's a beautiful close-up of a coral. These guys have cnidocytes, which are the special stinging cells. So if you've ever been stung by a jellyfish, or some people do have a reaction to sea anemones, it's because of these particular special cnidocytes, those stinging cells. Their barbs will shoot out, and that part right there, and there's a close-up of it, will embed itself into your skin. Now, we've all heard, if you've got stung by jellyfish, you can pee on it, and it's because it's changing pH. You can use vinegar, changing pH. You can use meat tenderizer, changing pH, and salt. And what you're doing is you're denaturing this protein right here. You're killing that, okay? As soon as you're able to do that, you're good. The other trick that I've heard lifeguards, that students of mine even lifeguards have told me, is you take sand and you scrub it in really good, because what you're basically doing is you are sanding out these barbels out of your skin. The one type of jellyfish you never ever ever want to use vinegar with is the box jellyfish. It is the most dangerous jellyfish in the entire planet. Portuguese man o' war is not the deadliest. It is the box jellyfish. I'm going to show you a picture in just a little bit. Nematocysts specialized nidae containing stinging thread that can penetrate the body wall of the prey. That's this right here. You got 4 clades, right? Evolutionary clades. Think of your evolutionary tree. Hydrozoas. These are alternate between polyps and medusa, so they'll have both body plans. They are colonial. Obelia is an example of this. You've got the scyphozoans. Medusa is a major part of the life cycle. Body plan, most are coastal. We'll have the polyp stage. That's your jellies. Many are bioluminescent. It's a cold light though, meaning that there's no actual energies required or given off. It's a mixture of chemicals that are produced by enzymes, kind of like a glow stick. Cubozoas, cube, box-shaped medusas. That's your box jelly right there. That is the most dangerous jellyfish. Notice he's grabbing it at the head. The head of a jellyfish does not contain the nematocyst. You can grab the top of the box of any kind of jellyfish, you're fine. I still wouldn't play around with box jelly personally, but to each their own. Box jelly are really, really small. That is not box jelly. This is box jelly because box jelly is really, really small. The nematocysts are found here in the tentacles. Just grab the top, no problem. These guys, cubozoans, are very, very strong swimmers. They have complex eyes. Not eyes the way we think of eyes. Eyes in the sense that they can sense light. They're less likely to wash ashore. They have very toxic nematocysts. Like I said, these are the ones you do not want to use vinegar with. If you actually use vinegar with these guys, instead of denaturing the proteins, it actually causes the nematocyst to shoot even more. Box jellies, if you get stung by them, they're only found in Australia so far. Lord knows invasive species can always change. But it is a matter of minutes to hours, if you're lucky, before they cause death. So it's a huge, huge issue. Sea wasp also belongs to this particular group. The sting is very intense. Respiratory failure can occur, cardiac arrest, and death can be within minutes. Anthozoans, these are only known as polyps. They're solitary or colonial. Many have a calcium carbonate skeleton. That's your sea anemones and your corals. So anthozoans are sea anemones, antha, anemone, and your corals. Okay. Corals obviously are the rainforests of the oceans. Global warming, pollution, and overfishing is killing them drastically. All right, most animals belong to clade Bilateria. Bilateria meaning they've got bilateral symmetry. 2 halves, right? Bilateral symmetry, they've got triploblasts, so they've got endoderm, ectoderm, and mesoderm. Most of the digestive tract and mouth and anus. The lophophore is a crown, that's right here. Beautiful crown, showing how they actually feed, filter feed. A crown of ciliated tentacles that feeds, some have this. Then you've got the phylum Platyhelminthes, that means your flatworm. So here's a beautiful cut, bilateral symmetry. If I cut it down the middle right here, I have 2 perfect halves, right? Typically anything that's going to have a head is going to have bilateral symmetry. Flatworms, you can find them in marine, fresh, damp environments. Some are free-living, some are parasitic, like your flukes, your tapeworms, everything from microscopic to 20 meters long. That's 60 feet. A tapeworm that is 60 feet long. 6 stories high, people. Start thinking about that in somebody's stomach, intestines. Ugh. They are triploblastic, but they are acoelomates. That means they do not have a true coelom, a true body cavity. We're going to talk about that in a minute. All right, these guys, you've got free living species. Flatworms, these are so cool. They have these eye spots. You can see them well on your PowerPoint. So right there, and they'll sit there and they'll move around. Planaria are so cool. Would have been awesome to have them in the lab. And you can watch them and they will go towards the light. It's really, really cool. And you can actually cut them in half and they'll regenerate. It's really neat. Anyways, parasitic species, more than half of them are parasitic. They typically have suckers, tough covering, and that right there is the sucker where they latch on inside of the stomach lining and just hang out there. Trematodes, many hosts, have a complex life cycle. Blood flukes, they'll have 2 hosts, the snail and the human. This is a very common issue in parts of the world that are developing countries where there's poor water hygiene. Okay, they'll trick the immune system for up to 40 years, and that'll just growing inside of the human. And then they'll defecate, poop in the river, and it'll continue the life cycle. go become the host, find a host of a snail. Snail will then release a larvae, which will then go into a human, and it'll keep really going through that same life cycle over and over and over again. Tapeworms. That is a very, very, very long tapeworm. That is the head of a tapeworm. Do you see those hooks right there? That is why it is so good at latching itself inside of you. The anterior end, the scolex, has hooks to attach the interior wall. Posterior to the scolex is a long ribbon. See that long ribbon? Of units called proglottics, which is just sacs of sex organs. Any one of these breaks off, and you have a brand new tapeworm. They're going to look like grains of rice in fecal matter. So let's say your dog, all of a sudden, his poop starts to look like he's got rice in it, and you're going, wait a second, my dog doesn't eat rice. Chances are your dog has tapeworms. Okay? Phylum Retifera, apologies, those are called beetle bearers. That's this one right here. They are so cool to watch. They will swim and they will pivot around and they will do all these flips and 360s and all this cool stuff. They can be found in freshwater and saltwater, damp soil, smaller than most protists. They are pseudocoelonates, meaning that they have a false body cavity. I'll explain that a little bit better in a little bit. Phylum Ectoproda and Brachiopoda. Ectoprodes are colonial animals that resemble clumps of animal moss called bryozoans. All right, that's all of these really cool examples right here. Most live in the ocean, and most are widespread, numerous sessile, stationary, stays in one place. They're important reef builders, very important. Some have been identical for 400 million years. All right, there's a fossil, and there's one right now. Pretty darn similar, right? Mollusks. These include your snails, your slugs, nudibranchs, for example. Naked snails, okay, in the ocean. Your oysters, your octopi. Octopi is the plural of octopus, or the other one, which I really hate, please don't say it, octopuses. And most seashell organisms, they have soft bodies, usually protected by some kind of shell made of calcium carbonate. They've got three main parts to their body: the muscular foot, the visceral mass, and then the mantle. They've got 8 classes inside the mollusks. You're going to want to be familiar with them. The chitons. The chitons are made of 8 shells. 1, 2, 3, 4, 5, 6, 7, 8 shells. And the bottom is like the bottom of a snail. They're cool. That's the first one. Gastropods. Gastro means stomach. It's supposed to be an M. Pod is foot. Stomach foot. That's your snails and your slugs and your nudibranchs, remember? Okay, about 3/4 of all living mollusk species are gastropods. They'll have a single spiral shell if they have one. Slugs obviously don't. In development, they'll undergo torsion, in which the body portion rotates 180 degrees, causing the anus and the mantle to be right above the head. So snails are actually walking around with the butts above the heads. Fun facts. Bivalves. Two. If you've got 2 shells, you're bivalves. So clams, mussels, scallops, oysters, all of that are your bivalves, okay? I would be showing you all of my awesome things that I've had on the shelves, but that's okay. These guys have flattened shells with 2 hinged shells together, a reduced head and paired gills. They will have an area, a siphon, where water comes in, and then an exit siphon where water exits. Look at that, beautiful. Beautiful. Cephalopods. That's your squid, your octopi, your cuttlefish, your chambered nautilus. All of them are marine. All cephalopods marine. Their head is surrounded by grasping tentacles. The shell can be external, the nautilus, internal, cuttlefish and squid, or completely absent, as is the case for the octopus. They'll have a closed circulatory system and very well developed sense organs and brain. In Galveston, where my husband and I went for grad school, for undergrad, they actually studied cuttlefish and nautilus as part of the University of Texas's neurological science program to understand better. You will have a cuttlefish that will be swimming right over the sandy bottom, and that cuttlefish looks beautiful, just like pure sand. And then it'll hit a rocky, this rocky shore area, not rocky shore, sorry, these rocks, and all of a sudden the cuttlefish is going to look like it's got projections coming off of its back, and makes it look just like it's 3D. Here's what's crazy. The cuttlefish's eyes are actually above on the top of the animal, right? So how in the world is it able to see beneath it, to see what the bottom of the ocean floor looks like, to be able to mimic it on the top, for its top? So it's like, okay, I'm swimming over here. Oh, I'm over the computer, right? Well, the top of the octopus, the eyes are here, yet somehow it's able to see beneath it and match, have the top of the cuttlefish match what's beneath it. It's really amazing. If you have a chance, please look up some videos on the cuttlefish. They're really, really cool. Annelids, segmented worms. Your earthworms are hermaphrodites, okay, both male and female parts, but can also reproduce by fragmentation. Break them in half, they'll reproduce. Tube worms are marine worms that build tubes made of their own mucus and sand. And leeches may be parasites or predatory, depending on the situation. That's your beautiful earthworm. Hopefully you guys have all seen the earthworm dissections we had posted on the website. Nematodes. So, let me double back. Annelids, segmented. They have segments. Look at that. Those are segments. We see those lines right there. Those are segments. Nematodes, no segments. It's a straight worm. There's no segmentation, no separation. Those are your roundworms. They're pseudocoelomates. Your annelids, your segmented worms, they are coelomates. They have a true body cavity. So when the worm stretches, all the internal organs can stay in their spot. They're not going to move with it, okay? Pseudocoelomates, there's no real separation. So when it moves, everything's going to move with it, okay? So basically what I'm saying, if you have a true body cavity, when you stretch out, you don't want your heart moving. You want your heart staying right there, right? Okay, so that allows you to move and have everything stay where it belongs. That is being a coelomate. So if you're a coelomate, if you have a true body cavity, that's going to allow you for more active movement. Kind of think of it that way. Pseudocoelomates with usually a tapered posterior and a rounded, blunt anterior. This is your heartworms, your pinworms, your hookworms. Arthropods, this is your crustaceans, aka your crabs, your lobsters, okay? Spiders, insects. Most successful phylum by far, based on species distribution and sheer numbers, species diversity. Coelomates that are segmented have a hard exoskeleton made of chitin, just like fungi, and jointed appendages. The exoskeleton is chitin. Open circulatory system, and gas exchanges through gills and water, and tracheal systems on land. Cheliceraforms, this is your horseshoe crabs, your spiders, your scorpions, your ticks, your mites. This right here is a very beautiful black spider with a red hourglass on its abdomen. Any ideas what that might be? Hopefully you guessed black widows, and that is 100% correct. Chelicerae, those are little feeder right there, feeder appendages. Pincers or fangs used for feeding. Two main body parts, anterior cephalothorax and posterior abdomen. So the front and the back. Anterior front, posterior tush. 6 pair of appendages, chelicerae, pelipads, used for sensing, pelipad to feel around, okay? And 4 pairs of walking legs. Spiders have what we call book lungs. These are really, really cool. Take a second, look it up. It's really cool. Don't need to know for my class, but just cool to know. Arthropods, these are your millipedes and your centipedes. What the heck is the difference between a millipede and a centipede? Very simple. A centipede has 1 pair of legs per segment. A millipede has 2. That's it. It's that simple. I'm going to say it again. A centipede has 1 pair of legs per segment. Millipedes have 2. I'm making a big deal out of this. You might want to write this down. Star it. Write it down. Know it. You know what I'm saying? Millipedes have 2 pairs of legs per body segment. Centipedes have 1. Oh, look at that. Know it. I miss y'all. Hexapoda, insects, springtails. 3 distinct body parts. The head, the thorax, the abdomen. Most are terrestrial with 3 pairs of legs and a pair of wings. Your butterflies, your flies, your moths, all the cool stuff. You got lots of different types of insect orders. Notice none of them are highlighted. No, you don't need to know them. Crustaceans. You better know examples of crustaceans, especially considering me. Crabs, lobsters, shrimp, crawfish. 2 to 3 body parts with chewing mouth parts, 3 or more pairs of legs. Some have cuticles that are hardened by calcium carbonate. forming a carapace over the cephalothorax. These guys will molt as they grow. You guys, when they molt, it is such a perfect replica of the actual animal that one time I had a shrimp molt in my tank a long time ago when I was in high school. Yes, again, no comment. I was like, my shrimp's dead. My poor shrimp is dead. And then about 4 hours later, I went, wait a second, I have a second shrimp. And then I went, oh, I'm an idiot. No, he actually molted. And that's all it was. And it is truly a perfect replica. It's really cool. Echinoderms, 5. If it's got 5 on it, it's an echinoderm. So, sea cucumbers, starfish, sea urchin, sea biscuit, sand dollar. If you really start looking at them, you'll start seeing that 5 pattern on top of them. They've got a water vascular system that connects the tube feet, and especially starfish, they're going to have an opening on the top of the starfish called the madreporite. That's where the water comes in, through which the entire starfish is able to control everything else. You're going to need to know that for your dissection quiz when I get that up and running. This includes your sea stars. Yes, they no longer call them starfish, they call them sea stars. It's also not a ball of gas in the water, so why we insist on calling it sea star, I don't know. Sea urchins, sand dollars, and sea cucumbers, amongst others. Now we're switching to chordates. You're going to want to know the 4 specific characteristics of chordates. I'm going to go over that in just a minute. Now, there's 2 subphyla that are invertebrates within the chordates. So this is a connection between invertebrates going to vertebrates, right? We have to have that middle section. That's urochordates and the cephalochordates. That's your tunicates and your lancelets. Your coelomates. So if you are a chordate, you're going to have a notochord, which is a primitive backbone. You're going to have a dorsal hollow nerve cord, pharyngeal gill slits, and post-anal tail. Those are the 4 characteristics that all vertebrates have to have. All chordates have to have. At one point in time, every single animal that has a backbone has all 4 characteristics. We had a post-anal tail during early development. That's why we call it the tailbone if you fall hard on your tush, right? Because past the tailbone, you had a tail. It disintegrated, but we had a tailbone. At one point during early development, we had pharyngeal gill slits, and then they closed up. We still have a notochord and dorsal hollow nerve cord, spine, right, and your backbone. We done. Chapter 33, done.